Good morning, my YouTube viewers. It's Crystal here. I just wanted to make a code review for you. In this code review, I'm going to be talking about Predict Proba. And in order to do Predict Proba, I'm going to use Kaggle's motorcycle habit prediction. Predict whether a driver will consider riding a motorcycle on a particular day. And we're going to be using Predict Proba. So you can see here, I've entered this competition. In order to enter the competition, I'm allowed to use 2 notebooks. And so the notebook that I've ticked on the bottom is Motorcycle Prediction version 4, and that is logistic regression with class weight set to balanced. And the top notebook that I have selected to submit for assessment is Predict Proba, Motorcycle Prediction Predict Proba. So version 4 is logistic regression. I'm sure a lot of people know how to use logistic regression, so I'm not really going to go into that notebook because Motorcycle Prediction Predict Proba is almost identical to that, except for the fact that instead of using logistic regression predict, we're using Predict Proba, and I'm going to show you how I did it. I mean, basically what it was I entered this competition, and you can see, I've put together a lot of notebooks, and the first notebook, which was the sample submission, was 47%. And then the second notebook, I used logistic regression, but I didn't set the hyperparameter up to class weights as balanced. And as a result of that, I only got 50%. But whenever I set my class weights to balanced, I got 69%. And the reason why is because in this particular data set, there is a class imbalance of approximately 70% ones and 30% zeros. So what we'll do is, we're not going to do 2 notebooks in this video, we're only going to do 1 notebook. You can see that this is my highest score, 69% is my highest score. So we're going to go on to version 7. So we're going to, and by the way, this is on my Kaggle account as well if you're interested. So we're going to talk about the problem statement. This is a playground competition based around binary classification and motorcyclist behavior living in Moscow, Russia. Sometimes it is too cold to ride a motorcycle, sometimes it's nice weather outside, but sometimes it's cold but there's no rain. Is it possible to make a prediction based on the date and weather if he will ride a motorcycle? Quite likely. So that's your problem statement. So this is a classification problem. It's a binary classification problem. So you have either a 0 or 1, not ride or ride. So the first thing that we're going to do is we're going to import our libraries, which are NumPy as NP, and so that performs numerical computations and creates NumPy arrays. We're going to import Pandas as PD, which performs data processing and creates data frames and series. We're going to import OS, which goes into your operating system to retrieve the files. We're going to import matplotlib.pyplot as PLT, which is graphics, which is a graphics library, and we're going to import Seaborn as SNS, which is another graphics library that's written on top of Matplotlib. Then we're going to read the files. We're going to use OS to do that, and we're going to call up all the files that are in the operating system, and the files that are in the operating system are train, test, and sample submission, so you can see that right there. We're going to read these files and convert them to data frames using pandas, and we're going to convert it to data frames using train, test, and submission. So you look at the train file, you've got 256 rows by 24 columns. And you see the last row is Y, which is your target. Look at the test file, which is 110 rows by 23 columns. And you don't have the Y because that's what you're going to have to predict on is your Y. And then you have your submission, which is what Kaggle, which is the format that Kaggle wants to see when you submit your predictions to Kaggle. So what we're going to do is we're going to analyze the train and the test files. So we're going to do info, and when we do info, we find out that all of the columns are numeric columns except for column number 1, which is a date. It says it's an object, but it's a date. We're going to check for any null values. We have 0 null values. We're going to check test for any null values. And we've got 12 null values in test. So there are several ways that you can deal with that. Either you can impute the null values, or you can just remove the columns for the null values. And so I decided I did it both ways. One way I imputed it, and then another way I removed the columns, and it didn't make any difference to my score, so I just removed the columns. Now we're going to analyze the target. Target equals train Y. Train equals train drop Y axis equals 1. And then we're going to use Seaborn to make a his plot of it. So you can see that you have a class imbalance. You have about 70% ones and about 30% zeros. And what I could have done, which I didn't do, and I'm not going to do because I've used up all of my submissions for the day already, is I could have done a value counts on Y. And then if I did a value counts on Y, it would have been close to 70% ones and 30% zeros. But I can't do the value counts because I've used all the submissions for all of my submissions for the day, so I'm not going to do it again. Now we're going to combine our train and test file. Combi equals train.append test. So you can see now we've got one big file called Combi of 366 rows and 23 columns. Now we're going to drop the IUD because the IUD is not necessary because all of the rows are identified by the index. We're going to drop RR mean, min, mean, and max. And the reason why I did that is because I tried to impute it on one of my notebooks. Made no difference whether I imputed it or dropped it. So I just decided to drop it. We're going to timestamp the data. We're going to use pandas to timestamp the data. And then we're going to drop the time because it's not needed, because when you timestamp the data, it creates a new column, so we don't need the time anymore, so we've just dropped it. We're going to get the month and day from your date time. And so when we do that, we're going to create 2 more columns called month and day. So you can see here, month and day. Now we're going to create a heat map, and when you create the heat map, you can see the columns that have a low correlation and the columns that have a high correlation. So the columns that you want to look at are going to be the columns that have a high correlation, because those are the columns that you're going to want to remove, because they have a lot of redundancy and they can introduce noise into the system. So we're going to remove columns that have a high correlation. You can see the shape of core is 20 columns, 20 rows by 20 columns, so it's 20. And now we're going to remove the columns that have a high correlation. And we've reduced it by 5 columns, so now we've only got 5 columns. We're going to check for missing values in Combi, and we don't have any missing values, so that's good. Then we're going to normalize Combi, and when you normalize Combi, what you do is you convert all of the cell values to values between 0 and 1, and the reason why is because the computer works better if the values are close together. And one thing I will say, that one thing that I have noted is that even though, strictly speaking, you don't have to normalize when you use logistic regression. That's what I've read, that you don't need to normalize on logistic regression. But whenever I was using logistic regression on my notebook, I got an error, and it said to standardize. It said you could either increase the iterations or standardize it. So I increased the iterations and it didn't help it. So I had to normalize it. So even though in theory you don't have to normalize with logistic regression, I found out that in this instance I did have to normalize. So it's just something to keep in mind. So what we do is we define our dependent and our independent variables. Your dependent variable is y and your independent variable is x. Y is your target, x is Combi 0 to the length of train, and x test is Combi the length of train to the end. And now what we're going to do is we're going to create our train and validation sets by using sklearn's train test split. And so we check the shape of that as well. So now we're going to use logistic regression. And then we train and fit our model. You notice we've got max iterations at 500, random state at 42, and class weight is balanced. And the reason why you set class weight to balance is because there's a class imbalance, and that's why you have to set class weight to balance. And it does improve your score. If you don't set class weight to balance, you're going to have a low score. So we got 64% accuracy when we set our class weight to balance. And now we're going to predict on the validation set, and instead of using predict, we're going to use predict proba. So proba equals model.predict proba xval, print model score xval yval. So that's just telling you what the score is, and that's 46% on that one. Top proba equals proba, and it's all of the columns and column number 1. And remember that in Python the first number is 0. And then it says print top proba. So we printed top proba right here. So what we're going to do now is we're going to create the variable called ypred. And ypred is a blank array. For I in range len xval, if top proba I is greater than or equal to 0.5, pred equals 1, else pred equals 0. And then you append pred to ypred to create the array, and then we print ypred. So you can see we printed ypred right here, and it said you can check the accuracy of it. Accuracy equals accuracy, yval ypred, print accuracy, and it's 46%. So you've got accuracy on that, on the ypred, and you've got accuracy on the, you've got accuracy in both instances. Okay. So then we do our confusion matrix. When we do our confusion matrix, you can see that we've got 4 zeros, which are true zeros, and 7 ones, which should have been zeros. And then you got another 7 zeros, which should have been ones, and 8 ones. So you can see it doesn't have a very good accuracy. And so, but I did my best. And then so now what we do is we put in a data frame to compare our y-val to our y-pred. And you can see that. And now we're going to predict on the test set, and we use the exact same methodology on the test set that we used on the validation set, with the exception of the fact that we didn't use print model.score because there wasn't anything to score, because that's what we have to score on. And instead of y-pred, we had predictions. So we've got our predictions. We've got our we've got our predictions here. And then we've got our, we've got our predictions. And see what it says. Top proba prep test. This is your top proba test. And then we've got our predictions here. And then we have our sample submission. We prepare our sample submission. So submission Y equals predictions. Submission.toCSV, we're going to convert it to a CSV file, equals submission.csv, index equals false. My submission equals pd.read CSV, submission CSV. And then my submission, and you can see this is my submission, what I submitted to Kaggle. So you take it all the way up, you can see that I got a 69% tile, which if we go back here, and we go to the leaderboard, said that I'm number 3. My highest score was 69%, and I'm number 3 on the leaderboard. So this was a very hard competition question to enter if I'm number 3. Because I don't profess to be a top A1 programmer, because I just tried to program well to get on the leaderboard. But if I'm number 3, you can tell it's a very hard competition. So I'm going to go ahead and close this video because we've covered the code review, which is what I want to do. And you can see that if you went and looked at motorcycle prediction here, number 4, it would be exact same as this one, except that I used logistic regression and I did predict instead of predict proba, and so that's why I'm not going over it, because well, I will show it to you, just the predict part of it. So you can see here it's logistic regression. In here I just used predict, and it gave you exactly the same score. You got the same score with predict that you would get with predict proba. But the difference between predict proba is that if you want to change the percentage at which it becomes a 1, you can do that. And what I was doing is I was reading up about Predict Proba because I knew I wanted to do a blog post on Predict Proba. And so let's just say hypothetically you are in the medical field and you want to predict on people that have cancer. And so that's a very serious thing to predict on. So what you would do is, rather than having the top proba being 0.5, you might have the top proba being 0.95. So that means that 5% of the people would have cancer. So anything above 0.95, they have cancer, but anything below 0.95, they don't have cancer. So that's when you would use Predict-Propa and something like that. And I just used having cancer as an example, but I'm sure that there's lots more examples, although I can't think of any right off the top of my head. So that's it. That's it for the code review. We've covered the code review, we've covered Predict-Propa, and we've covered Predict. We've covered logistic regression. So I've covered everything that I would like to cover. So I would like to thank you for watching my video and thank my subscribers for supporting my channel. And if you like my video, please like, subscribe, and share. And I look forward to making more videos for you in the future.